Mhm. All right. Yeah, I can't. You can't hear me. Wow. Why? We can't hear. Hello? You can hear me or not? Yes. Okay, very good. You can hear me. Right. I just asking a question. Okay. You can scan your QR code. Okay. I sent already to your Telegram. Okay. Never mind. I can send again here. All right. Let's I share screen with you all. All right. I stop sharing. Yeah, share screen with you. Okay, you can. All right, you go to the this one. All right. So you can see here. Okay, I will clarify your attendance today by small games. All right, by a small games, but prepare the calculator because we want to apply linear least square method. All right, do a summation of the xi, summation of the siyi, and so on. So this is a very simple, okay, very simple, um, uh, okay, exercise. Okay, don't worry, all right, don't worry, because just I want to clarify your attendance, all right? Okay, okay, finish already. Okay, scan your QR code. Okay, I have Danish here, Ahmad here, Fikri, Paravan here, Krishan. All right, Fikri. Okay, we have many students here. All right. Okay, you said that before this, I just ask you a question. Maybe you don't hear my voice. And then after this, inshallah, you can hear my voice. So apa khabar? I hope you stay safe. Now COVID increase, okay, very fast. I don't know what types of a wave nowadays. Be careful, okay, especially people who are having the experience with a positive COVID, okay, because they are carrier. So be careful and then take care of yourself, okay. Good food, good vegetable food, and so on. All right, who are staying in the village, you are okay. I think this opportunity for you, okay, because the environment really make you help. All right, so now today we are going to learn about, all right, numerical differentiation. All right, we go to the chapter 5. We go to the chapter 5. Chapter 5 is very important because chapter 8 and chapter 9 will use chapter 5. Okay, this is a very basic for the finite difference method when you are applying numerical in your life. Okay, so to do the discretization process, we need chapter 5. All right, discretize the ordinary differential equation, ODE, or partial differential equation, PDE. We learn solving a PDE or ODE using calculus, but okay, now we are going to apply Taylor series to discretize the first order derivative and second order derivative. All right, so this is the objective we meet today. What is the objective? To learn the formula comes from the Taylor series, all right, and then discretize the numerical differentiation, okay, using first order or second order derivative. Okay, means that dy over dx, how to do that in numerical. D squared y over dx squared, how to do that in numerical aspect. All right, so welcome Piravan. All right, so now I stop sharing. I want to visual the content at the e-learning. Okay, you can go to the e-learning. All right, okay, I'm stop sharing. All right, I go to the e-learning again. Okay, there is my e-learning. Okay, this is my learning. I already post to you the YouTube and then the PDF file. All right, and then I stop sharing. I go to my lecture today. Okay, about chapter 5. What is chapter 5? Is numerical differentiation. All right. Okay. Let's we bring for the early stage. Okay, I hope I'm alone here. Okay, I'm alone here. When I invite people, they not come in. So today I'm going to invite you for the next time. Okay, I hope when I invite you, you join my class, and at least you can give a feedback whether you understand or not my class. All right. You can also chat. Okay, you can also chat with me at the top chat YouTube, but you need to register. Please register at the YouTube, and then you can start asking a question. I will calculate. Okay, I will also consider your chat. Okay, with me means that once you register, you can get marks for that day. All right. So now let's I focus my lecture. Okay, come on, we can focus our lecture. Our lecture is about how numerical differentiation support the basic of the finite different method. What is a finite different method? All right, this is a method to discretize the ordinary differential equation and partial differential equation. What is a partial differential equation? It's like heat equation, wave equation is considered as a partial differential equation where the temperature or the wave is depend on the space x and y, and also spend some time when you deal with the heat is depend on time. All right, so how to write dy over dx or d squared y over dx squared, all right, in the numerical differentiation manner. In this case, we are using Taylor series. All right. So now, let's we go to the books. Come on. I'm looking that you have a books and calculator in front of your computer. All right. So when we draw the graph, for example, I have a 3 point. Forward is x plus h. Backward point is x minus h. I have a point for fx plus h, fx, and fx minus h. The graph I can write as a y equal to fx for x axis and y axis. So now my function is to find the gradient. Okay, what is the keturunan? Gradient for x fx. Meaning that I need to use df over dx. All right, the first derivative f respect to x. Okay, now I want to apply Taylor series. So now let's we go to your book. All right, go to your book. To the ebook that I already upload at the e-learning. Okay, go. You can get in page 117 the formula, the formula of the Taylor series, all right, 5.1, 5.2, 5.3, 5.4. We are going to use 5.1, 5.2 repeatedly to represent the first order derivative, for dy over dx, using forward, backward, or center different formula. All right. So the Taylor series for 5.1 is a fx plus h. 5.2 is a fx minus h. 5.3 f plus x 2h. And 5.4 is for fx minus 2h. It's just x is a forward, 2 point forward, or x backward and 2 point backward. X plus h, x plus 2h. And the backward, x minus h, x minus 2h. That's all. All right. So we can use how many points now? 5 points to represent the graph. All right. So now let's we continue again the graph. All right. So what is our objective now is to find dy over dx or y prime or f prime x. All right. So we want to find numerically. This process we can call as a finite difference method, or when you deal with the chapter 8 and chapter 9, we call as a discretization of ODE or PDE. All right. So what is the first derivative of y using center different formula. Center means that we are covering the point backward and forward. All right, we are using fx plus h, fx plus h, fx x, fx, and x minus h, fx minus h, the coordinate. All right, the coordinate. So now we go to the your book, Taylor series fx plus h 5.1 and Taylor series 5.2 fx minus h. So I replace y to f. Why? Because now I'm looking for f is any function, so I'm using del f over del x equal to fx plus h minus fx minus h divided by 2h. That's we call as a center different formula. 1 point at the back, 1 point at the front, all right, divided by h. H is a size of interval of the data. So h is a delta x, okay, delta x. Now, let's prove using Taylor series, okay, for the, we want to prove that the center different formula, okay, using Taylor series can represent as del f over del x equal to f plus x minus fx minus h divided by 2h. All right. So this is the formula center different formula. Okay, center different. So come on, we go to the 5.1. Okay, I write again the formula of Taylor series. Okay, for x plus h. All right, is a come on, we write one by one. Fx plus h f prime x plus h squared divided by 2 factorial f prime prime x plus h power 3 factorial f prime 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 x plus, plus is the same expression but higher order, h power 4 divided by 4 factorial f prime 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 x plus up to OH power n. All right. So this is the formula that we give in 5.1. All right. We also give the formula for Taylor series, for x minus h, function on your backward, of the point, or at the back of the point. So the formula same as 5.1. However, h is a negative. We negative h, meaning that h power 2, even they are positive. H power odd, they are negative. So the answer is fx minus h is a fx minus h f prime x, plus h power squared divided by 2 factorial f prime prime x negative minus h power 3 divided by 3 factorial because odd number, a negative 1 power odd number is negative times f prime 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 x plus h power 4 divided by 4 factorial f prime 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 x plus OH power n. All right, so this is a standard Taylor series to represent the function fx plus h or fx minus h. You can refer to 5.1 and 5.2. All right, so come on. I give you two formula to represent the function of x plus h using Taylor series, order 3 maximum, but we are focused on order 1. Order 1. All right, so now from 5.1, from 5.1 you can get formula for forward different formula. For 5.2 you can also get the formula of backward different formula, but we want to focus on the center different formula. Let's concentrate on how to prove center different formula. All right. Now we minus f.1 and we minus 5.1 and 5.2. All right. When you minus this formula, all right, you will get fx plus h minus fx minus h, equal to 2hf prime x. The rest we put as 0 because we want to focus on the first order only. Second order, is a OH power 2 lah. Is an approximation solution, meaning that we do a transcation error up to the second order. All right. So you minus and then you divide by 2h, you can get f prime x, all right? But if you don't want to divide by 2h also can, you will get fx plus h minus fx minus h, 5.1 minus 5.2 divided by 2h equal to 2h f prime x. So if you want to divide it, meaning that 2h on your right hand side. So you will get f prime x equal to fx plus h minus x minus h divided by 2h. So proven already. Okay, you can prove how to get the first order derivative x based on the center difference formula. Where is the point? Come on, come on, come on. We drag. Okay, we drag again. Okay, I love to present in the graph. You see my graph? All right. Okay, you can see. Okay, when we want to use a center difference formula, we need to find the point forward x plus h and the point backward x minus h. All right. So for backward is only x and x minus h. All right, 2 point. And then for forward is also 2 point x plus h forward minus fx. All right. So remember this graph because we want to apply to prove, okay, forward different formula. We want to prove forward different formula. Okay, how to prove this? Okay, you can use the Taylor series. Which part? Okay, you can go for 5.1. Okay, the above that I wrote, and then minus fx divided by h. Or okay, you just bring the okay, you just stop at the f prime x only. All right, you can stop at the f prime x. The second order f prime prime we put as oh power 2. All right, we do a transcription error up to power 2, the second order derivative. All right, so now df over dx is a 5.1 minus fx. Come on, okay, you divide it by h, so you will get, all right. Come on, in this case, f prime prime we ignore as a oh power 2. There is an error. However, the small error we consider as small error. So you focus only h f prime x plus 0 h power 2. All right, h f prime x plus oh power 2. All right, so that one we do the approximation. That's why I'm not saying equal, but approximation. All right. So from here you can find that df over dx is a f prime x, where f prime x is what? Is a fx plus h minus fx divided by h. H is a delta x. So the same formula, okay, to get a forward, you are using formula 5.1. So now my question, how you want to prove the backward different formula? In this case, you are using Taylor series 5.2. All right, what is a 5.2? It's a fx minus h, okay, equal to fx, okay, still remember, minus h prime plus h power 2, all right, f prime x divided by 2 factorial, and then this one is a h negative, kan? Negative h power 3 divided by 3 factorial f prime prime. This one should be negative because the formula for fx minus h is every h should be negative. Odd value, h power negative, h power odd is a negative. So you will get h f prime x, okay. Right, you can see here minus 0 is a h f prime x divided by h. So you can prove that f prime x equal to df over dx, where you apply the formula for 5.2 to get a backward different formula. All right. So now, since you know how to get the formula for 2 point, okay, different formula of first order derivative. So my question, okay, my question here. All right. You go to the how many formula that you learn now from the Taylor series. All right. Okay. Till now, you are using 3 formula for first order derivative: forward, backward, and center different formula. So 5.5 is a forward different formula. 5.6 is a backward different formula. Easy to remember. And then 5.9 is a very center different formula. Come on, we go. I can't find the this one. Center different formula is a 5.8. All right. So you have three formula. What is a three formula? All right. It's a backward, forward, and center different formula. Just deal with the point. Okay. Just deal with the formula from Taylor series. All right. So now we can also write the first order derivative using 3-point backward different formula. So that's, I'm asking a question. How you can prove the third point, okay, backward different formula. Before this, we just remember all in 2 point, but now 3 point. Okay, so you go to page 120. This is the formula 5.9. You need to consider, okay, Taylor series for fx minus h is a 5.2 and fx minus 2h is a 5.4. All right, you just replace in the backward 3-point different formula 5.9, so you can prove this point. So now you have 4 formula to represent first order derivative dy over dx. Right? So now, come on. I want you to go to the example. Let's we go to the example. Okay, stop sharing. Okay, stop sharing. Okay, we go to the example. Better we go to example. Okay, you go to the this one. Okay. All right. So in this book, in this video, I'm using a book. Come on, go to the book. Okay, go to the book. Okay, page 111. Okay, 117. All right, and then this is a formula for the Taylor series. Okay, 5.1 for fx plus h. 5.2 is for x minus h. 5.3 for fx plus 2h. And 5.4 fx minus 2h. Just about x 1 point forward, 2 point forward, or 1 point backward, or 2 point backward. Right? 5.1 up to 5.4 is a Taylor series that we are going to generate the forward different formula. Okay, forward different formula for first order derivative. Come on, I'm using 5.1. I will get fx plus h equal to fx plus h f prime x. So I will get f prime x is a f plus h minus fx divided by h. Alright, what is f? F is a function at the y-axis here. 5.2, you can see 5.2, I can get backward different formula. What is that? Fx plus h minus fx divided by, fx minus h divided by h is a forward different formula. Since this is just a grid, a point at y-axis, I can write in the discretization style. I don't want to write in this coordinate. I want to make it more easy. F prime I equal to fi plus h, fi plus 1 minus fi divided by h for forward different formula, meaning that f plus x plus h, I write is fi plus 1. And then for the backward, for I minus minus 1, I will write too fast. For x minus h, I will write as a f prime I equal to fi minus 1 divided by h. I just put I to represent x minus h to I minus 1. All right, x minus h as a I minus 1. It's easy to remember. All right, so now I can also write the formula for the 5.8. It's a center different formula. I'm using fx plus h minus fx minus h. Okay, I'm using 5.1 and 5.2 formula. All right, what is the formula for the center different formula? Well, it's very easy. okay, just 5.1 minus 5.2, you can get, okay, fi prime equal to fi plus 1 minus fi minus 1 divided by 2h, all right? So I just replace x plus h or x minus h as a I plus 1 or I minus 1. Easy to remember, all right? Because I is a grid, x plus h is a coordinate. I just replace from coordinate to grid. Easy to understand. All right. So now, wait for a while. Okay, I would like to ask a question from you all. Okay, the question is why we need numerical differentiation. Why we need numerical differentiation? Okay, come on, somebody can answer me? All right, very good. Okay, why we need numerical differentiation? Why? Why we need chapter 5? Right? Okay, can you give a reason why? Why we need to have four formula for first order derivative? Forward, backward, center different formula, and 3-point backward. Why we need so many formula? So this is my question. All right. So please answer. Okay, please answer my question. Why we need numerical differentiation? All right. Come on. Let's be more bigger. Okay, you can see very clear here. All right. So now, let's we go to the second derivative. Okay, before we go to the second derivative, all right, I would like to share with you some information here. Okay, we go to the our notes here. Okay, now the next question that I want to ask you, how we want to apply the second order derivative. Del squared f over del x squared. Why? Okay, why we need to learn second order derivative? All right. The first order derivative just now we learn because what? Because we want to find the gradient, keturunan positif ke negatif. All right. For the second order derivative, we learn because we want to find whether the graph have the maximum, minimum, or the saddle point. We want to investigate the point. So when we do the second order derivative, okay, because we want to find whether the graph is positive or negative, okay, maximum or minimum. And if you want to go for the other application, okay, acceleration, kan, the fast, the speed, all using the first order derivative and second order derivative. Velocity, we are using the second and first order derivative. All right. Okay, you need to remember this one. All right. So now, Liu said that, okay, we need to learn numerical differentiation because to find the maximum and minimum point. Yes, second order derivative. Very good. And then Fikri said that describe the algorithm to estimate the numerical derivative of the numerical function. I know Fikri said like this. Okay, we have the alternative. Before this, when we have a question very complex ODE or complex PDE, you can go to the numerical. You can go to the calculus. But sometimes when deal with the trigonometry, deal the very complex function, all right, you need to find other alternative software, for example, to make it like a simulation very fast. So this is the meaning of the Fikri is you use a numerical derivative, okay, to replace the calculus. Okay, to replace the calculus. Very good. All right. Okay. Okay. Very good. All right. So now we go to okay, how to discretize the second order derivative? So the formula is from Taylor series is a 1 over h fx plus h minus 2fx plus fx minus h divided by h squared tadi lah. Alright. So this is we can prove using Taylor series. Very easy. Okay, we apply Taylor series fx plus h 5.1 and then fx minus h 5.2 in the formula, and then you can get the you can confirm that the formula is correct. All right. There are so many ways. Okay. For example, you can use a basic calculus to prove the second order derivative. There are many ways. Yeah. This one is the simplest based on the numerical aspect. Numerical aspect. All right. So how to how to write in the discretization form, because sometimes in the coordinate kan, that one is a value at the y-axis. This coordinate you can put in the discretization form in the subscript I. Your f prime prime I equal to 1 over h fxi plus 1 minus 2 fi plus fi minus 1. All right, so means that I plus 1 is x plus h. H is the size of interval to forward. X minus h means that you have a point at the backward. Okay, I will draw already the graph. So the discretization process is very important in chapter 8 and 9, all right? Because we are using numerical differentiation to do the finite difference method or to do the discretization. Now, you need to remember, this is not the ending. You need to use chapter 5 to solve chapter 8 and chapter 9. All right? All right. Okay. So now, I think this is the end. All right. But we want to go to the example. All right. We want to go to the example for the second order derivative. Okay. We stop sharing. Let's go to the another part. All right. Is how to. All right. This one. How to solve a graph to find the first order derivative, second order derivative for the specific point. All right, for the specific point. Okay, I told you there is two formula for second order derivative. The first is you use a Taylor series 5.1 and 5.2. You do the plus 5.1 and 5.2 minus 2fx. You will get the second order derivative based on 3 points. What is the point? 1 over h squared fx plus h minus 2fx plus fx minus h. Alright, divided by h squared tadilah. Alright, the other one is a 3-point center, 5-point center difference formula. That's involve x plus 2h and x plus x minus 2h. Where you get from the graph, you need to have another 1 point forward, another 1 point backward, where the distance is 2h, right, from x, right? So now I write in the discretization pattern is a fi plus 1 minus 2 fi plus fi minus 1 divided by h, right? So 5.11 I can replace as a second order derivative. All right, so come on, please remember this is the way how to make it easy to remember and then very fast writing. All right, so now let's go to example. Okay, you go to the example, you are given a data. Okay, the data is uniform. Okay, the data is uniform. Okay, I'm stop here. Okay, I want to ask somebody here, what is a uniform data? Uniform. I already what is uniform data? Okay, this is my question here. All right, so can you answer my question? All right, what is a uniform data? I'm using uniform data because h is a size of interval. It's a similar for every part. Okay, 2 point above and then 2 point forward, all similar. H 0.1. All right. So that is uniform. What it means by uniform data? So this is my question. All right, so let's refocus again to the next step. I have how many questions? 6 questions. Okay, the first question is a first derivative using forward. The second question B is a first derivative using backward. And then the third, okay, is a first derivative using center difference formula. Which is more accurate? For me, okay, center difference formula accurate because they go beyond. They go to 5 points, okay? They go to the 3 points, sorry, not 5 points. So let's say your x is a 2.0 Your x plus h is a 2.1. Your x minus h is 1.9. Your x plus 2h is 2.2. Your x minus 2h is 1.8. You have 5 points. All right. However, using find it different, we choose a point at the center, f prime 2.0. You can use forward, backward, or center. All right. Just fit in fx plus h, okay, is a forward. All right. You go to the forward. All right. fx minus h is a backward. Okay. 12.7032. So you have a 3 point here. All right. 1.9, 2.0, and 2.1. So you can answer easily, okay, using a simple 2-point formula of the first derivative. Right? Okay, let's restart. Okay, we start after knowing all the point, and your xi is a 2.0. All right, your xi plus 1 is a 2.1, and your xi minus 1 is a 1.9. All right, so now I want to solve f prime 2.0. Okay, this is your I plus 1, and I minus 1. All right, so this is the way how we write I plus 1 and I minus 1. I minus 2 is on your left. Okay, so this is a formula for the forward, fi plus 1 minus fi divided by h. Okay, I just transform the formula to the discretized. Very easy for me to write. Okay, delta x, okay, is a h. H is size of the table 0.1. You get from the table. All right, this is a uniform. All right, so now, okay, we want to find f prime I equal to fi plus 1 is what? Is a 2, f 2.1 is a 17. It's a 17.1789, all right? And then minus, okay, minus, okay, let's I correct it. Okay, this one is correct. And then minus fi. Fi is a f 2.0 is a 14.7781 divided by 0.1. All right. So what you get? Okay, I'm waiting. Please press your calculator. All right. Press your calculator. Okay. Where is your calculator? All right. Press your calculator. Come on. Let's press it. Okay. Divided by 0.1. All right. Okay. All right, come on, press your calculator. Where is the calculator? Okay, you will get, okay, is a 1.5408. Okay, yes, the same formula, okay? All right, so 1.5408. Okay, that's we are using forward different formula. All right. So now, we go for the second. The second is using the backward different formula. Just apply where is the xi minus 1 is a 12.7082. Right? So by replace the backward, okay, you can get 1.4182 for backward. It's almost approximate using the forward. But now we want to use center different formula. We go to the center different formula. All right. Fx plus h minus fx minus h divided by 2h. All right. Please, you need to remember. Very simple to remember. Okay. Where is x plus 1? 17.1489. Where is fi minus 1? Is 12.7082. So you have 1 point forward and 1 point backward. All right, so the formula is fi plus 1 minus fi minus 1 divided by h. Your h is 0.1. All right, and then put fi plus 1, where is 17.1489. Fi minus 1, 12.7032 divided by 2h. Don't h, yeah? That is wrong. Divided by 2h. So what is the answer? All right, not divided by 0.1. 2h. 2 times 0.1. The forward different formula is 22.2285. Forward 23.7080. All right. Backward is a 20.7090. So the error you can see, okay, if you compare with the exact solution, they give you exact solution. Okay, the center difference formula, the error is only 0.1357. All right, center difference formula is only 0.0613. However, the error for absolute error is that I told you just now is 1.54 and 1.41. It's big, very big. Okay, by using the forward and backward compared to center. Center you spread, okay, your data to the forward and backward. Kan? Now, I want to answer the second order derivative. Wow, there are so many formula for the second order derivative, all right? Even though the first order derivative, then I express here also many, okay, plus another three formula. It's a 3 point backward and then 3 point and then the 1, 2, 3, 4, 5. 1, 2, 3, 4. 4 point formula. All right. So you can add in, you can go and then compare to the exact solution. So you from the comparison, you can see that when you increase the point, the graph is very accurate, and then the error is much more accurate. So you can see the error smallest up to 0.0005. The error, okay. Okay, when you go for f is a 4 point first order derivative. The error is much very low, 0.0005. Right. Okay, kan? So in this case, we can conclude that when you are using F or G, the error when you compare with the exact solution is much more near. Means that the error is much more zero. Okay, near to zero. Right. So why we are using many point, because the process of accuracy become very good. All right. So you can see here. I asked the question, what is the uniform data? The differentiation between the point is a similar. H will be the same. Very good. Thank you very much. Okay. So I'm applying the numerical differentiation to find the first order and second order derivative. All right. So now let's go to the second order derivative. All right. So what is the example here? Come on. We go to the example. We want to find f prime 2.0 again. Why we need second order? Because we want from the graph here, okay, when you get a data, you draw the graph is increasing. Means that there is a optimum level, there is a maximum level of the graph. So when we do the second order derivative, means that we want to find the notation of the graph, whether positive or negative. All right. So come on, we go to the second order derivative. Let's find. All right. For the second order derivative, I'm using 3 point. Okay, 3 point formula. And I'm also using how many point? 1, 2, 3, 4, 5. 5 point. Okay. Second order derivative. So which one better? I think B is better. Okay. You are using 5 point involving 1 point forward and another point, 2 point forward and 2 point backward. Okay. X plus 2H and X minus 2H. Right? Okay, now let's go to the second order derivative, meaning that I need to find I plus 1, I minus 1. Second order derivative, I need to use all these 3 points, fi plus 1 minus 2fi minus plus fi minus 1 divided by 2h, okay? Oh, sorry, by h squared, okay? That one we can prove using Taylor series. We can using a Taylor series. All right, so now f prime, okay, at 2 is a fi plus 1 is a f 2.1 is a 17.1489 minus 2f 2.0 is a 14.7781 plus f 1.9, okay, 1 back is a 12.7032 divided by 0.1 squared. All right, so you can get the answer for the second order derivative. Come on, what is a second order derivative? Whether positive or negative? Yeah, is a positive. Okay, if you can see here is a positive. All right, So f prime prime is a positive. What is the positive value? Is 29.5900. So when you go to the second order derivative, the error is 0.0338. Now, if I want to use the 5 point number B, I think the result is much okay. Yes, okay. You can see the error is 0.0045, very small. So in this case, okay, when you use many point, the graph is very good. However, we are not focused during the examination for more than 5 point, okay, like 9 point, 11 point. No, we are using 3 point, 2 point, or 5 point. All right, so now my question, how many formula that you learned until now? How many formula? All right, first order derivative, you have 4, plus here you have another 1, okay, and you have 5, okay, for the first order derivative, 2 point, 3 point, and 4 point. Second order derivative, you have, just now we learned 2 plus 1, you have how many point? You have 3 formula. So you have 8 formula now, okay. However, you need to follow the instruction, whether you want to use forward, backward, center, higher order of the differential equation. All right. So it's very simple. Okay, very simple. Okay. Any question? All right. So any question? All right. So this is a start. What you need to do? Okay, you need to find your ebook. Okay, notes, book here, calculator. All right, because you need to do the exercises. All right, you can familiar with the fx plus h, 1 point above forward, xi minus h, 1 point back, x pass 2h, okay, 2 point, okay, the size of interval, okay, is a 2h, okay, 2 point forward or 2 point backward. All right, so that's all. You're familiar with it. And then the formula important is a centered different formula. 3 point second order derivative. We don't go for the 5 point, okay, because it's not easy if I ask you to do that, because okay, you are not researcher. You just apply the numerical differentiation. Okay, any question? All right, any question? I'm asking a question. If you have any question, please address here. Okay, which part you not understand? Okay, so I already fulfilled my objective while we learn chapter 5. Okay, and then how chapter 5 involved to do the discretization for chapter 8 and chapter 9. All right, and then some exercises which is help you to recognize, okay, what is a f prime x, what is a f prime prime x. X is a point maybe at the centers, okay, or not at the corners. It's not like Newton forward, Newton backward, at the centers, okay, because almost the second order derivative and first order derivative, the point using 1 point above and 1 point backward. All right, so any question? There is no question. Are you sure? Okay, you just introduce yourself to the numerical differentiation. It's okay. All right. And then I would like to share with you now. I would like to share. I close here for a moment. I want to share with you before we go for the simple games. Okay, don't worry. Okay, I'm not too much. Okay, I just want, okay, the exercise is not burden you. I just want to make sure that you can share with your friend. Share with your friend. Okay, how to solve the exercise start from 3.2, 3.3, 4.1, 4.2. I distribute the question among the groups. Okay, please answer the question, and then you can share, okay, the answer with your friend. You can get the answer straightforward how they do it. All right. Okay, and then you can follow if there is a question related on the least square method, quadratic least square method, you turn backward, forward, or divided, you can answer. All right. Okay, come on. I put some duration to make sure that you can answer on time. All right. So that's all. Okay, let's we continue to simple games. Okay, to clarify your attendance today. All right. To your make sure that your attendance. Okay, your contribution. Okay, to this class. Okay, um, is a regular, committed, and so on. Right. So your friend here, dear, group we tired has 2 questions lah. Tak apalah, Chuang Zuan, tak apalah. Why I put 2 questions? Because simple. That's why I put 2 questions. There is a few questions, a few group also. I put 2 questions because simple. Don't. Oh, ni pula. Among is not there. Among ada kan? Tak ada. Among tak ada. Alright, so never mind. I will take notes. Okay, among is not there. Alright, never mind. I will remind. Okay. Oh, you also write at the Telegram. Okay, never mind. You remind me. I will put among here. Alright. So now, okay, let's share with you. Okay, take your handphone. Alright, take your calculator. Put in front. Alright, go to the quiz.com. It's simple, don't worry. Okay, I just want to make sure that my class can follow me or not, because you are staying home, I'm staying at home. So how we can communicate each other, all right, without we have what we call this one is just to make sure you can okay, together with me. Okay, almost our class. Okay, come on, we go to the all right, here. Okay, let's start. Okay, come on. There is no prayer, sorry. We just oh, sorry. All right, I sent to your quizzes. Okay, this is a QR code, and then this is the link. Okay, come on, I can go to the link. Okay, I write the link. Okay, you just click. Okay, now. Okay, wow, Go is here now. All right, thank you very much joining the quiz. Okay, don't worry. We just want to make sure that you can press your calculator. Summation SI, summation YI. That's all. All right. Summation SIYI. That's all. I want to make sure that you can press. Okay, the question is take a few minutes. Okay, 5 minutes. Okay, long time. All right. Don't hantam. All right. Okay, Chu, Cham, Chai, Rifat, Lo, Ong, Ko, Arun, Kwa, Pri, Raven, Liu, Lim, Chong, Calvin, Sai, Peh, Azman. Come on, please put the correct name. RJ apa? Raju or what? Islam, Jia. Please put the correct name. Eng, Jia, March, Fikri. I know Christian. Okay, Saifuddin. Come on. RJ is what? RJ is what? Come on. All right. Change your name. All right. If not, I can remove you from here. You come again with a new name. You don't use an anonymous name. All right, because I'm not easy to find your attendance. Bala. Okay. Arun. Okay. T. Wow. Okay. Many here. Okay. I'm waiting all of you. Okay, to join my class. Why? Because I just want to remind myself how the overall of my student to focus on the student-centered learning. The process of learning here is what? Student-centered learning. Okay, student-centered learning. All right. So come on, we are looking the participant from you all. Okay. All right, so now it's 40 plus. Okay, this is the quizzes, and then the QR code. You can refer to your Telegram too. All right. Come on. Okay, I'm waiting. Okay, RJ, you can change your name. Okay, now 42. There are 60 plus 60 students here. I hope the attendance will be balanced. Okay, will be balanced. All right. So I have the online attendance using the QR code. All right. Come on. Okay. Mm-hmm. Take time because I give you lots of time, all right? Okay, plenty time for you to press the calculator, all right? Where is the calculator? I just want to make sure that you know how to find summation x, summation SIYI, summation, summation SIYI and others, all right? So, okay, since we are waiting from others to join us. Okay, let's we go to your e-learning, or you can go to your Telegram to see the question here. All right, to see the question. I just want to make sure that you can answer this question, and then you can you can delete dulu lah. Okay, delete dulu. All right. So this is a question. Okay, never mind. You can doctor change already. Ah, Rikin Jibon, Rikin RJ. All right. Sorry. Thank you very much. All right. So now, can I play now? Can I start? Okay, let's we go to the message here. Okay, can we start? Okay. All right. The rest we can come okay to the maybe the line or whatever. Can we start? So let's we start. All right. You can join the quizzes. Never mind if you are late. All right. Can we start? Let's start. okay, you cannot come in again, okay, if you terminate and then you come in again, okay, of course you can get a high ranking, but never mind, okay, we already record, okay, never mind. Now let's we end the session, okay. I have 77 accuracy, okay, and then I have 24, okay, full marks, okay, the rest is half, and then there is a few still not answer the question. All right, okay, come on, let's we go to the conclusion, okay, that we get from the today, okay. Thank you very much, okay. I think the second Bala, I'm not sure you come early or you come to the quizzes, I'm not sure. All right, so we go to the let's we go to the Control C, Control V. Okay, come on. I have many students. Okay, have a 100% here. Okay, congratulations. Okay, if you come many times, of course, you have a high rank. Okay, however, okay, you cannot come many times because when you correct, you can get the first rank. Okay, actually in the quizzes. So the first people who are, come on, we go to the record at the Telegram. The first people who are get a full mark is me. I'm not sure. Ahmad Osama, the first one. And then now they continue to other people, all right. So it's depend on the how much time they spend for answering the question. All right. But however, I would like to all of you, okay, and then try again and again. Inshallah, you can get a better result. All right, come on. This is the answer. Okay, you can see here. Okay, there are 24 out of the 35, okay, have a full marks. The rest, okay, half correct, half wrong. Okay, come on. I send to you to your Telegram, okay, the question. And then the second question, all right, the second question is here. Okay, I just want to make sure that you can find the summation x, summation y, summation siyi, and summation si squared is correct. And then to get the error between the 1.1 plus 1.3x, and then the data given is a y 25387 to get A, B, C, D, and E. All right, we want to minimize the error using, we can minimize the error using Caltrite least square method. Okay, never mind. We can try again. Okay, for the next quiz, and good luck. Okay, any question? Any question? If you have no question, we stop here and see you at the Padlet. See you at the Padlet. All right? Okay. Bye-bye. Okay.